good evening, and welcome. However you came to find this quiet place tonight, and wherever in the world you happen to be, I'm really glad you're here. Maybe you're already tucked into bed, with the blankets warm around you and the lights turned down low. Maybe you're at the end of a long and tiring day, or resting somewhere far from home in the small, still hours of the night. Before we begin, I'd love to know one small thing. Where in the world are you listening from tonight? If you feel like it, leave a little note below to say hello and let us know where you are. There's something lovely about the thought of so many people, scattered right across the world, all quietly settling in to rest at the same time. And if these calm recordings help you unwind and drift off, at the end of the day, a gentle like and a quiet subscribe help this little channel more than you'd think. Now let me tell you where we are going to wander this evening. Tonight, we are going to go back, not to last week or last year, or even 1,000 years ago, but all the way back, as far back as it is possible to go, to the very beginning of everything there is. Tonight, we are going to tell the story of the Big Bang, the moment unimaginably long ago, when our entire universe began. We'll find out what the Big Bang actually was and what it was not. We'll watch the young universe cool and grow and take shape, step by gentle step, from a formless glow into the first stars and galaxies, and onward, across billions of years, all the way down to this quiet room where you are lying now. It is, quite simply, the oldest and grandest story there is, the story of how everything came to be. I promise there will be nothing difficult here. There is no science to study, no long words to learn, and there is certainly no test at the end. If anything, I hope this feels less like a lesson and more like being told a slow, wondering bedtime story about where the whole world came from. And if you happen to drift off to sleep somewhere along the way, long before we reach the end, please don't feel that you've missed a thing. That is exactly what this is here for. It would be the loveliest possible way to spend the night. So make yourself as comfortable as you possibly can. Sink a little deeper into the pillow, let your shoulders fall, and close your eyes whenever they feel ready to close. Take one slow, easy breath in and let it slowly out. And let us begin, gently, at the very beginning of time. There is a question so old and so simple that nearly every person who has ever lived has stopped to wonder about it at least once. Perhaps you wondered it yourself as a child, lying awake and looking up at the ceiling in the dark. The question is this: where did everything come from? Not just where did you come from, or where did the world come from, but where did all of it come from? The ground and the sky, the sun and the stars, the whole vast everything. Was there ever a time when none of it was here at all? And if there was, then how did it all begin? For most of human history, no one had any real way to answer this. People told beautiful stories about it all around the world, and those stories brought comfort and meaning. But no one could truly know. It seemed like the sort of question that would always stay a mystery, forever out of reach. And yet, and this is one of the most remarkable things about the little stretch of time we happen to live in, over the last 100 years or so, we have actually begun to find an answer. Not a complete one, not by any means, but a real one, built carefully out of what we can see and measure in the sky. And that answer is the story we now call the Big Bang. And I think it is worth pausing right here at the very start, simply to marvel that we can say anything at all about this. Think of what we are attempting. We are trying to work out how the entire universe began, an almost inconceivable length of time ago, long before there were any people, or any world, or even any stars to see it happen. And we are trying to do it now, from the inside, using nothing but the faint light that reaches us across space and the patient work of careful thought. It really ought to be impossible. And yet, little by little, by looking very closely at the sky and following the clues wherever they led, we have managed to piece together a real and surprisingly detailed story of the beginning of everything. It is one of the most remarkable things our species has ever done. And the loveliest part of it is this: we did not have to invent the story or simply guess at it. The universe told us in its own quiet way, in the slow drifting of the galaxies, in the faint afterglow that still fills the sky, in the very substances that everything is made of. We only had to learn how to listen, and tonight, gently, and with nothing to prove and nowhere to be, we are going to listen to that story together. So let me tell you, right at the start, in the simplest way I can, what the Big Bang actually means. The Big Bang is the name we give to the beginning of the universe, the idea that everything there is, all of space, all of time, all of matter and energy, began an unimaginably long time ago from a single, incredibly hot, incredibly dense state, and has been expanding and cooling and unfolding ever since. That is the whole of it, really. Everything that exists was once gathered together, hot and dense beyond imagining, and then it began to grow and to cool, and out of that slow growing and cooling came, in time, the stars and the galaxies and the world and you. Now, I have to pause here and clear away the single most common misunderstanding about all of this, because the name itself leads us astray. When we hear the words Big Bang, we naturally picture an explosion, a great blast, like a bomb going off, hurling bits of matter outward through space in every direction. It is a very natural picture, and it is wrong. The Big Bang was not an explosion that happened at some particular spot in an already existing space, blowing outward into the emptiness around it. That is not what happened at all. Here is the truth of it, and it is a strange and lovely thing to hold in your mind. There was no space around it for anything to explode into. Space itself was part of what began. When we say the universe was once small and dense and has been growing ever since, we don't mean that a lump of matter sat in the middle of a vast empty room and then expanded to fill it. We mean that the room itself, space, the very stage on which everything happens, was small and has been stretching larger ever since, carrying everything along with it. The Big Bang did not happen at one place. It happened everywhere, all at once, because everywhere was, at that moment, the same place. Every single point in the universe you can imagine, including the exact spot where you are lying right now, was there at the beginning. The Big Bang happened right here, in this room, and out among the farthest stars, and everywhere in between, all at the same time, because all of it was, once, gathered together as one. Perhaps the gentlest way to picture this is to imagine the surface of a balloon, with tiny dots drawn all over it. Think of those little dots as the galaxies, and think of the stretchy surface they sit on as all of space. Now imagine the balloon slowly being blown up, larger and larger. As it swells, every dot drifts away from every other dot, because the whole surface they are painted on is stretching. And if you were a tiny creature living on one of those dots, you would see all the other dots moving away from you in every direction. But you could search that entire balloon forever and never find a center, never find the one special dot that all the others are fleeing from. There simply isn't one. Every dot moves away from every other, and none of them sits at the middle. That is very much how it is with our universe. There is no special place where the Big Bang happened, no center from which everything is rushing outward. It happened across the whole of space at once, and every point is drifting away from every other, and there is no middle to be found anywhere at all. We are not at the center of the universe, but then, rather comfortingly, neither is anyone else. I know that is a difficult thing to picture, and please don't worry if it slips away from you. We will come back to it gently and let it settle. For now, just hold the simple heart of the idea that everything began together, small and hot and dense, and has been growing outward and cooling down ever since. And then let us ask the next natural question, the one that first led people to this whole strange and wonderful idea. How could anyone possibly know such a thing? What could we ever see here and now that would tell us how the universe began so long ago? The first great clue, the thread that, once pulled, slowly unraveled the whole story, came from looking outward at the other galaxies, those vast distant islands of stars scattered far across the depths of space. And what the astronomers found, when they looked carefully, was something that nobody had expected, and that changed our whole picture of the universe. They found that the galaxies are moving, almost all of them, in almost every direction we look, are moving away from us. And not only that, they are moving apart from one another. The whole universe, it turned out, is growing. Let me tell you how they could tell, because it is rather beautiful, and I'll keep it gentle. When light comes to us from a distant object, it carries information hidden inside it, written in its color. And it turns out that when something is moving away from us, its light gets very slightly stretched, shifted a little toward the red end of the rainbow. When astronomers looked at the light from the distant galaxies, they found that almost all of it was stretched and reddened in just this way, which meant that almost all of those galaxies were moving away from us. And the farther away a galaxy was, the faster it seemed to be racing off. The most distant ones were fleeing fastest of all. It was as if the entire universe were quietly flying apart. Now at first, this might sound rather alarming or lonely, as though our galaxy was somehow being shunned, with everything else rushing away from us in particular, as if we had done something to offend the whole cosmos. But that is not what is happening at all, and the truth is far gentler and far stranger. It is not that everything is fleeing from us. It is that everything is moving away from everything else, all at once, in every direction. Space itself is stretching, and as it stretches, it carries all the galaxies apart from one another, like markings drifting apart on the surface of something that is slowly growing. The picture I find most helpful here is a simple loaf of raisin bread, rising in a warm oven. Imagine the dough with raisins dotted all through it, and imagine that you are one of those raisins. As the dough rises and swells, every raisin moves away from every other raisin. From where you sit, you would see all the other raisins drifting away from you, and the ones farthest away would seem to move away the fastest, because there is more swelling dough between you and them. But you are not special. A raisin on the far side of the loaf would see exactly the same thing. Everything drifting away, and the distant ones fleeing fastest. No raisin is at the center. The dough itself is simply growing, everywhere at once, and carrying all the raisins apart. That is what is happening to the universe. The galaxies are the raisins, and space is the rising dough. Space itself is swelling, growing larger everywhere at once, and it carries the galaxies apart as it grows. We are not at the center of it. There is no center. Every galaxy sees the others drifting away, and every galaxy could, with equal truth, imagine itself to be the still point at the middle of it all. But none of them is. The whole thing is simply, gently growing. It is worth pausing, just for a moment, to feel how enormous a discovery this was. For the whole of human history, up until quite recently, people had imagined the universe as a fixed and settled thing. The stars fixed in their places, eternal and unchanging. A vast still stage upon which everything else happened. The idea that the entire universe might be growing, that space itself might be quietly stretching larger with every passing age, was a genuine shock, and it took people a good while to truly believe it. But the evidence was there, written plainly in the light of the distant galaxies, and it only grew stronger the more carefully anyone looked. And you might wonder how anyone could measure such a thing, how we could possibly know not just that a galaxy is drifting away, but how far off it lies, across such unimaginable distances. It is done, in part, by a rather clever trick of brightness. There are certain kinds of stars and certain kinds of events in the sky that always shine with very nearly the same true brightness, so that if one of them looks faint to us, we know it must be far away, and if it looks brighter, we know it must be nearer, in much the way that a candle looks dimmer the farther off it is carried. By finding these dependable lights inside the distant galaxies, astronomers could work out how far away those galaxies truly were, and by matching that distance against how fast each galaxy was racing away, they slowly built up the whole gentle picture of a universe steadily expanding. And this was the great clue, the one that opened the door to the entire story of the Big Bang. Because once you know that the universe is growing, that everything is gradually spreading apart, that space is slowly swelling larger and larger with every passing age, a very natural and very powerful question suggests itself. If the universe is bigger today than it was yesterday, and bigger this year than it was last year, and has been growing for as long as there has been a universe at all, then what was it like long, long ago? If everything is flying apart now, then in the distant past, everything must have been closer together. And if we follow that thought back and back and back, as far as it will go, where does it lead us? Let us follow it now gently into the deep past. Here is a simple and rather wonderful way to think about the whole thing. Imagine that you had a film of the entire history of the universe, a recording of everything, from now stretching all the way back to the beginning, and imagine that you began to play that film backwards. What would you see? Well, we know that right now the universe is expanding, the galaxies all drifting apart, space slowly swelling larger. So if we ran the film backwards, we would see the opposite. We would see all the galaxies drawing closer together, instead of farther apart. We would watch the whole universe slowly shrinking, contracting, gathering itself in. The galaxies would crowd nearer and nearer to one another. The vast empty spaces between them would narrow and close. Everything that is now spread so thinly across such enormous distances would be squeezed together, tighter and tighter, as we ran the film further and further back toward the beginning. And as everything was squeezed together, something else would happen. Something you already know in your bones from the ordinary world. When you squeeze things together, they grow hot. We touched on this before, perhaps. Pump air into a tire and the pump grows warm. Squeeze anything into a smaller space and its warmth concentrates and rises. So as we ran our film backwards and watched the whole universe being squeezed into a smaller and smaller space, we would also watch it grow hotter and hotter. The gentle cold of deep space running backwards would warm and then heat and then blaze. The further back we went, the smaller, the denser, and the hotter the whole universe would become. There is something almost dreamlike in imagining it, the whole grand universe, with all its scattered galaxies and all its empty gulfs, gently drawing itself back inward, like a long breath being slowly taken in. The galaxies glide back toward one another. The great dark spaces narrow and close. The scattered starlight gathers and brightens and merges, and everything grows warmer and closer and more crowded. The further back we run the film, until the whole cosmos is drawn together into a single blazing point of heat and light. It is a strange and wonderful thing to picture the entire universe as something small, smaller than a galaxy, smaller than a star, smaller than this very room, smaller than anything at all. And yet, that is exactly where the film leads, if we run it back far enough. Everything that now fills the endless reaches of space was once gathered into that single tiny blazing beginning. Keep running the film back. The galaxies themselves would break apart into the gas they formed from. The stars would come undone. Everything would dissolve into a hot, thick, glowing fog, growing hotter and denser with every step backward. And if we kept going, all the way back, as far as the film would run, we would arrive at last at a single moment. A moment when the entire universe, everything that would ever exist, was squeezed together into an unimaginably small, unimaginably hot, unimaginably dense state. And that moment, that beginning, is what we call the Big Bang. This is really the heart of the whole idea, and it is worth resting on for a moment because of how simple and how powerful it is. We did not arrive at the Big Bang by wild guessing. We arrived at it by looking at the universe today, seeing that it is expanding, and then simply following that expansion backwards in our minds as far as it would go. The universe is bigger today than yesterday, so it was smaller yesterday than today. So long ago, it must have been very small indeed. Run that thought to its very end, and it points, inevitably, to a beginning, a first moment, when everything was gathered together, and from which everything has been expanding ever since. Now, I should be honest and gentle with you here, because this is one of those places where it is important to say clearly what we know and what we don't. We can run the film backwards with real confidence for almost the entire history of the universe. But at the very first instant, the very beginning itself, that single starting moment, our understanding runs out. The conditions there were so extreme, so far beyond anything we can recreate or fully describe, that we simply do not yet know what happened in that very first sliver of time, or what, if anything, came before it. It is one of the deepest open questions there is, and we'll return to it gently later. But from a tiny fraction of a second after that beginning, onward through all the ages that followed, we can tell the story with growing confidence and growing detail. So let us pick the story up there, just after the very beginning, and watch what happened as the young universe took its first breaths. So let us stand in our imagination at the very beginning of things, as near to that first moment as we can safely go, and watch what unfolds. It is a strange place to stand, because none of the things we are used to exist yet. There are no stars, no planets, no galaxies. There is no gentle darkness of empty space, because space itself is only just beginning. There is only a single, unimaginably hot, unimaginably dense state, holding within it everything that will ever be. And then, in that first instant, it begins to expand. And it expands at the very start with a speed and a suddenness that is almost impossible to put into words. In the tiniest fraction of the tiniest fraction of a second, a span of time so short that there is really no way to make it feel real, the universe is thought to have grown from something smaller than the smallest thing you could imagine to something vast, swelling in size by an amount so enormous that the numbers simply lose all meaning. This sudden, staggering burst of growth right at the beginning is our best understanding of how things started, though I'll gently admit that the very earliest moments remain, in many ways, a frontier we are still exploring. But the broad picture is this: the universe began incredibly small and hot and dense, and then it stretched suddenly and enormously, and then it kept on growing, more gently, ever after. It is worth trying, just for a moment, to feel how utterly extreme those first conditions were, though the honest truth is that they lie far beyond anything our minds were ever built to hold. The heat was not the heat of a fire, or a furnace, or even the blazing heart of a star. It was a heat so far beyond all of those that they would seem stone cold beside it. And the density, the sheer crowdedness of everything, all pressed together, was just as far beyond imagining. Everything that would ever become every star and every galaxy in all the universe, squeezed into a space smaller than you could ever picture. And yet, out of that unthinkable extreme, everything gentle and familiar would in time come. The cool quiet of a night sky, the soft warmth of a bed, the slow calm of a sleepy evening much like this one. It all began in that fierce and blazing start, and it has been cooling and calming and settling ever since, across all the long ages, down to this peaceful moment now. And as it grew, it cooled. This is the rhythm of the whole story, the simple heartbeat beneath everything that follows. So let me say it plainly and let it settle. As the universe expands, it cools. It is the same rule, run forwards, that we used to run our film backwards. Squeezing things together heats them up. Letting them spread apart cools them down. So as the young universe swelled outward, all of its fierce, concentrated heat was spread through more and more space, and its temperature began steadily to fall. It began blindingly, ferociously hot, far hotter than the center of any star, hotter than anything that exists anywhere today. And with every passing instant, as it grew, it cooled a little more. At the very beginning, the universe was so hot that none of the familiar things of the world could exist within it. It was too hot for atoms, too hot even for the ordinary building blocks that atoms are made from. There was only a kind of seething, formless, blazing energy, filling everything, everywhere. Nothing solid, nothing settled, nothing like the world we know. Just an unimaginable heat, thinning and cooling as the whole of everything expanded. There is a reason, we think, that this sudden early stretching mattered so much, quite apart from simply making the universe large. When you stretch something out enormously, the way the skin of a balloon smooths out as you blow it up, its little wrinkles pulled flat, you also smooth it. And that great early stretch seems to have smoothed the young universe, ironing out what might otherwise have been a lumpy, uneven, chaotic beginning into something remarkably even and uniform, very nearly the same in every direction you could look. This is one of the reasons the universe today appears so wonderfully balanced and orderly on the largest scale, rather than a jumbled mess, because that first great stretch smoothed it gently and enormously in its very first instant. And yet, and this will matter greatly later in our story, it did not smooth it away perfectly. It left behind the very faintest of wrinkles, and from those faint leftover wrinkles, in the long fullness of time, everything else would grow. But cooling changes things, and this is where the story truly begins to become the story of us. Because as the universe cooled, step by step, it began, step by step, to take shape. Think of the way that steam, as it cools, becomes water, and water, as it cools further, becomes ice. The same substance, but as the heat drops away, it settles into new and more definite forms. Something a little like that happened to the whole universe as it cooled. At each stage, as the temperature fell past a certain point, the formless energy could settle into something new, something more structured, more permanent, more like the matter we know. And the first great step in that long settling was the appearance of the very first tiny building blocks of matter, forming out of the cooling energy all across the young and growing universe. Let us follow the story into those first few extraordinary minutes, when the first pieces of everything came to be. It is a remarkable thing to say, and worth pausing over, but the entire foundation of all the matter in the universe, the basic stuff from which every star and every world and every living thing would one day be built, was laid down in just the first few minutes after the beginning. Not the first few billion years, the first few minutes. In the time it might take you to soften and settle towards sleep tonight, the young universe worked out what it was going to be made of. Here is how it went, as gently as I can tell it. As the blazing young universe expanded and cooled, the formless energy of the very beginning began to settle into the first true particles of matter, the tiniest pieces, the fundamental little grains from which everything larger is built. And as it cooled further, those tiniest pieces began, in turn, to gather and join into slightly larger pieces, the first building blocks of what would become atoms. It all happened in a great hot rush, in those first fleeting minutes, while the whole universe was still hot enough and dense enough for these things to come together. And what was built in those first few minutes was the very simplest kinds of matter that exist. The universe did not begin with the rich variety of substances we know today. No carbon, no oxygen, no iron, no gold. It was far too hot and too hurried for anything so complex. Instead, it made, overwhelmingly, the two simplest and lightest kinds of matter there are. The lightest of all, which we call hydrogen, and the next lightest, which we call helium. By the time those first few minutes were over, and the universe had spread out and cooled just enough that this early building came to a stop, the great work was essentially done. The universe was, from then on, made almost entirely of these two simple light gases, a great deal of hydrogen, a fair amount of helium, and only the faintest trace of anything else at all. there is one more thing about those first moments that I find quietly wonderful and a little mysterious, and I'll share it gently because it touches on why there is anything here at all. When matter first came into being out of the young universe's energy, it seems to have appeared in two kinds: ordinary matter, the sort that everything around us is made of, and a kind of opposite, mirror image matter. And these two kinds share a strange and dramatic property. When they meet, they undo one another completely, both vanishing in a small flash back into pure energy. In the fierce early universe, the two kinds were forming and meeting and undoing one another constantly, and by all rights, they ought to have cancelled out entirely, leaving a universe of nothing but light. No lasting matter at all, no stars, no worlds, no us. But they did not quite cancel out. For reasons we still do not fully understand, there was the very slightest imbalance, a tiny surplus of ordinary matter over its mirror opposite, something like one extra particle left over for every billion or so that met and vanished. And when all the meeting and undoing was finally done, that tiny leftover surplus was all that remained. And that small remainder, the faint little bit that was left over after very nearly everything had cancelled itself away, is the matter that makes up the entire universe today. Every star, every world, every atom of you is built from that faint early surplus. We are, in a rather beautiful sense, made from the small remainder that the beginning did not quite manage to erase. I find something quietly astonishing in this. It means that if you could have taken a sample of the entire universe, in those early days you would have found it to be almost nothing but the two simplest gases, spread everywhere, evenly and thinly, filling all of the young and growing space, all the wonderful complexity of the world we know now, all the different substances, the metals and minerals, the air and water, the very stuff of our bodies. None of it existed yet. It would all have to be built later and slowly out of these simple beginnings. But the raw material, the primordial gas from which the first stars and galaxies would one day form, was made right there in the opening minutes of time. And here is a lovely thing. We can actually check this. We can look out at the oldest, most distant, least changed parts of the universe and measure what they are made of. And we find just what the story predicts: overwhelmingly hydrogen and helium, in very close to the proportions that the young universe should have made in those first few minutes. It is one of the quiet triumphs of the whole idea, this agreement between what the story says should have happened and what we actually find when we look. The recipe written in the first minutes of time is still legible, all these ages later, in the makeup of the universe around us. But for a long while after those first few minutes, the universe remained a strange place, a place unlike anything we would recognize. It was still far too hot for those simple gases to settle into complete, calm atoms, and far too hot still for light to travel freely. For a great stretch of time, the whole universe was a glowing, blazing fog. And then, at last, it cooled enough for one of the most beautiful things in the entire story to happen. The fog cleared, and the universe filled, for the first time, with light that could travel free. Let us watch that happen now. For a long time after the beginning, a stretch far longer than those first busy minutes, the universe stayed a hot, thick, glowing fog. And I'd like to help you picture why, because it explains something wonderful that we can still see today. In those early ages, the universe was still so hot that its matter could not settle into calm, complete atoms. The tiny pieces of matter were still flying about too fiercely, too energetically, to join together properly. And in that hot, restless state, the matter was scattered all through space in a way that got constantly in the way of light. Any light trying to travel through the young universe could not get far at all before it bumped into something and was knocked aside, and then knocked aside again and again. Light could not travel in a straight line across the universe. It could only bounce and scatter endlessly, trapped, unable to get anywhere. So the whole universe glowed, but you could not have seen through it. It was like the inside of a thick, luminous fog, or the blinding blank whiteness deep within a cloud. Bright, but opaque. Glowing, but impossible to see through. And then, as the universe kept expanding and kept cooling, a great change came. The temperature fell, at last, past a crucial point, cool enough, finally, for the matter to settle down. The tiny pieces slowed and calmed, and joined together at last into complete, quiet, stable atoms. The first true atoms of simple hydrogen and helium gas, spread all through space. And the moment that happened, the fog cleared, because those calm, complete atoms no longer got in the way of light, the way the hot, restless matter had. Suddenly, for the first time in the history of the universe, light could travel freely. It could stream across space in long, straight, unobstructed lines on and on, without being knocked aside. The universe, which had been an opaque glowing fog, became clear and transparent. It was, in a very real sense, the first moment that the universe became see-through, the first time light was set free to roam. And here is the truly beautiful part. That light, the light that was set free at that ancient moment when the fog first cleared, is still traveling through the universe today. It never stopped. It has been streaming across space ever since, for the entire age of the universe, and some of it is arriving at us right now, at this very moment, from every direction in the sky. It is the oldest light there is, the most ancient thing we can see, the afterglow of the young universe itself, the light from the moment the cosmic fog first cleared. And because the universe has expanded so enormously in all the ages since, stretching everything, including this ancient light, along with it, that light has been stretched and cooled and gentled from the fierce glow it once was into something very faint and very cold, a soft, dim whisper of warmth, filling all of space, just a few degrees above the coldest cold that is possible. But it is there. It is genuinely there, all around us, all the time. A faint and ancient glow coming from every part of the sky at once, the leftover light at the beginning of the world. And here is how we came to be sure of it, which is one of my favorite stories in all of science, and I'll tell it to you gently. Some years ago, two scientists were working with a large, sensitive antenna, trying to listen to faint signals from space, but they kept picking up a faint, steady hiss, a soft background noise that they could not get rid of, no matter what they did, and that seemed to come from every direction in the sky, at every hour of the day and night. They cleaned the antenna. They checked and rechecked their equipment. They did everything they could think of to track down the source of the annoying hiss and make it go away. And it would not go away. It was always there, the same faint whisper coming from everywhere. And in the end, they realized the extraordinary truth. The hiss was not a fault in their equipment at all. It was the afterglow of the Big Bang. It was that ancient light, the leftover glow from the moment the cosmic fog first cleared, arriving from every direction at once, exactly as the story of the Big Bang said it should. They had stumbled upon the faint, cold echo of the beginning of the universe, humming quietly in their antenna. And once we knew to look for it, we found it everywhere, a gentle confirmation, written across the whole sky, that the Big Bang really did happen. And when, in the years since, we made careful maps of that ancient afterglow, gentle pictures of this oldest light, gathered patiently from every corner of the sky, we found in it something more precious than anyone had expected. At first glance, the afterglow is astonishingly smooth and even, very nearly the same in every direction, a uniform whisper of warmth filling all of space. But when we looked very closely indeed, we found that it was not perfectly smooth. Woven faintly through it were the very slightest of patterns, patches that were the tiniest bit warmer, and patches the tiniest bit cooler than the rest. Barely there at all, fainter than almost anything. And yet, those gentle patterns turned out to be among the most important things we have ever seen. For hidden within them was the secret of where everything came from. So after the fog cleared, the universe was, for the first time, transparent and calm, filled with that freshly freed light, and with vast, thin clouds of simple hydrogen and helium gas, drifting quietly in the growing dark. But it was, in another way, a rather empty and lonely place, because there were still no stars, not one. But before we follow the young universe into that long and lonely dark, there is one more thing hidden in that ancient afterglow that we really must not pass by, for it holds the secret of how a smooth young universe ever became the great structured cosmos of stars and galaxies we know today. Let us linger a little on those faint patterns in the ancient afterglow, because they hold one of the loveliest ideas in the whole story, the answer to a question we have not quite asked yet. The question is this: if the young universe, in its early days, was so very smooth and even, a nearly uniform sea of gas, spread almost perfectly evenly through all of space, then how did it ever become the lumpy, structured, uneven universe we see today? For the universe now is anything but smooth. It has stars gathered into galaxies, and galaxies gathered into great clusters, with vast and echoing empty spaces in between. It is full of clumps and gatherings and structure. How did all of that come from such a smooth and even beginning? The answer lies in those faint patterns, those tiny warmer and cooler patches in the ancient afterglow. Because those patches are a picture, the oldest picture there is, of the young universe's very slight unevenness. In the early universe, the gas was almost perfectly evenly spread, but not quite. Here and there, it was the tiniest bit denser, the tiniest bit more crowded than elsewhere. Barely, faintly, almost imperceptibly so. Those very wrinkles that the great early stretching did not quite smooth away. And those faint patches of slightly denser gas are exactly what show up, all these long ages later, as the faint, warmer and cooler patterns in the afterglow. We are looking, in that ancient light, at the young universe's own gentle lumpiness, printed softly across the whole sky. And here is why those faint patches matter so enormously. You'll remember that gravity always favors a head start, that wherever matter is even a little bit denser, its pull is a little stronger, so it draws in more matter and grows denser still. Those tiny early patches of slightly denser gas were exactly the head start that gravity needed. Across the long ages that followed, Gravity worked patiently upon those faint patches, gathering more and more gas into each one, drawing them denser and denser, slowly turning the very slightest early unevenness into greater and greater concentrations of matter. And it was in those gathering places, those slowly growing clumps, that the first stars and the first galaxies would one day form. Every galaxy in the universe, our own included, grew from one of those faint patches of slightly denser gas in the young cosmos. So those tiny patterns in the ancient afterglow are, quite truly, the seeds of everything. The faint lumpiness of the young universe became, through the long and patient work of gravity, every star and every galaxy that exists. When we look at that oldest light and see its faint warmer and cooler patches, we are looking at the seeds from which the entire structured universe would grow, including the very seed that would one day become our own galaxy and our own star and our own world and us. The whole grand, structured, star-filled cosmos was written in the faintest possible outline, in the young universe's gentle unevenness, and it has been growing and gathering and taking shape out of those seeds ever since. And so, from the faintest wrinkles in the young universe, the seeds of every galaxy were quietly sown and left to wait, waiting, through the long darkness that was to come, for gravity to gather them and for the first stars to be born. Let us follow the young universe into that dark and patient age now. After the fog cleared and the ancient light streamed free, the universe entered a long, quiet, and rather lonely age. We sometimes call it the Dark Ages of the universe, and it is a fitting name, because once that first freed light had spread out and faded, there was, for a long stretch of time, nothing shining at all. There were no stars yet. There were no galaxies. There was only darkness and cold, and the vast, thin, invisible clouds of simple gas, the hydrogen and helium made in the first minutes, drifting silently through the growing dark. If you had been there to look, you would have seen nothing at all, just blackness in every direction, and the slow, cold, patient drift of gas through an empty and lightless universe. But something was happening in that darkness, slowly and invisibly, something gentle and patient and unstoppable. And that something was gravity. You remember gravity, that quiet, endless force by which every bit of matter pulls on every other bit, drawing things together across any distance. All through those dark ages, gravity was quietly at work on those vast clouds of drifting gas. The gas was not spread perfectly evenly. In some places, it was the tiniest bit thicker, the tiniest bit denser than in others. And gravity always favors a head start. Wherever the gas was a little denser, its pull was a little stronger, and so it drew in a little more gas, and grew denser still, and pulled harder still. Slowly, slowly, across millions of years of darkness, gravity gathered the thin, drifting gas into thicker and thicker clumps and clouds, pulling it together, concentrating it, squeezing it inward. And you already know what happens when gas is squeezed together tightly enough. It grows hot. As gravity pulled those clouds of gas inward, gathering them tighter and tighter, the gas at the heart of each gathering clump grew warmer, and then hot, and then blazingly, ferociously hot, until, at the very center of the densest clumps, the temperature and the pressure climbed so high that something extraordinary happened. The gas caught fire, not an ordinary fire, but the deep nuclear fire that burns in the heart of every star. And a star, the very first star, began to shine. Try for a moment to feel the wonder of that first light. After the ancient afterglow had faded, the universe had been utterly dark for a very long time, nothing but blackness and cold and drifting gas. And then, somewhere, in the heart of the densest cloud, the first star switched on and sent its light streaming out into the darkness. And then another, and another, here and there across the young universe, as more and more of those gathering clouds reached the point of catching fire, one by one, and then, in their thousands and millions, the first stars ignited, and the long dark ages came to an end. We sometimes call this beautiful moment the cosmic dawn, the dawn of starlight, the first time the universe was lit by stars, and the darkness, which had held for so long, was scattered at last by the light of the first suns. And those very first stars were not quite like the stars we know today, because they formed from the pure, simple gas of the young universe, nothing but hydrogen and helium, with none of the heavier substances that later stars would carry. They seemed to have grown into truly enormous stars, far larger and far more brilliant than most of the stars that shine now. They blazed with a fierce and dazzling light, and they lived fast and furious lives, burning through their fuel in what was, by the slow measure of the cosmos, a very short time indeed. And when those first giant stars came to the ends of their lives and died, they did something of enormous importance for everything that was to follow. In their blazing hearts, they had forged the very first small amounts of the heavier substances, the first carbon, the first oxygen, the first traces of the richer kinds of matter, out of the simple gas they had been born from. And in dying, they scattered these first heavier substances out into space, seeding the young universe with the earlier specks of the richer material from which everything more complex would one day be built. The first stars, in living and in dying, began the long, slow work of enriching the cosmos, the very work that would, in time, make worlds and living things possible. And the stars did not shine alone for long. Gravity, which had gathered the gas into stars, also gathered the stars themselves into great groups and gatherings, vast crowds of stars drawn together and held by gravity, turning slowly through space. And those great gatherings of stars are the galaxies. All across the young universe, as the first stars lit up, they were drawn together into the first galaxies, the first of those vast islands of light that fill the cosmos today. Our own galaxy, the great wheel of stars we belong to, was among those that began to form in this way, in the early ages of the universe, out of the gathering of gas and the lighting of the first stars. And so, out of the darkness, and by the slow, patient work of gravity, the universe filled at last with stars and with galaxies, and began truly to look like the universe we know. So the first stars had lit their fires, and the first galaxies had begun to turn, and the long dark ages were over. But the universe of that early time was still a simpler place than the one we know. It was made, you'll remember, almost entirely of the two lightest gases, hydrogen and helium, and very little else. There was no carbon yet, no oxygen, no iron, no gold, none of the rich variety of substances that make up the world around us, and indeed that make up our own bodies. So how did we get from that simple early universe, made of nothing but light gas, to the wonderfully varied world of today? How did we get from hydrogen and helium to trees and oceans and living, breathing people? That is the last great stretch of our story, and it is a beautiful one. The answer is that the stars themselves built everything else. A star, all through its long life, is a kind of forge. Deep in its blazing heart, it takes the simple light gas it was born from and, in its nuclear fire, presses it together into heavier and richer kinds of matter, building carbon and oxygen, and on, forging heavier substances from lighter ones, all through its life. And when a star reaches the end of its life and dies, as all stars eventually must, it releases much of this new, enriched material back out into space, gently, or sometimes in a tremendous burst of light, scattering all the richer substances it has forged out into the drifting clouds of gas between the stars. And then the cycle turns again. Those enriched clouds, now carrying not just the simple original gas, but all the heavier substances forged and scattered by the stars that lived before, are gathered up once more by gravity and form new stars and new worlds around them. And because these new clouds are richer than the first ones were, the worlds that form from them can be richer too, made not just of light gas, but of rock and metal and water and air and all the varied stuff of a world like ours. Some of the richest and most dramatic of this element making happened in the deaths of the largest stars. When a truly massive star reaches the end of its life, it can die in a tremendous burst of light, one of the most powerful events in all the universe. And in that great burst, it forges and flings out a whole wealth of heavier substances, scattering them far across space to enrich the clouds around it. Over the long ages, countless stars, large and small, lived and died and gave back their enriched material in just this way, generation after generation, slowly seeding the galaxies with an ever richer mixture of the elements. And then, something over 4.5 billion years ago, quite late in the long story of the universe, in one ordinary corner of our own galaxy, one of these enriched clouds began to gather itself together under gravity and drew itself in and formed a new star. That star was our sun, and from the leftover material swirling around it, there gathered the planets, including one modest world at just the right gentle distance that would in time become the Earth. Everything that has happened here since, every ocean and every forest, every creature that has ever lived, all of human history, and you, resting here tonight, has unfolded upon that one small world, built from the gathered ashes of stars that lived and died long before the sun was ever born. Generation after generation of stars lived and died in this way, each one forging a little more richness, each one seeding the clouds for the next, slowly enriching the universe across billions of years. And that is where we come from. Our own star, the sun, and our own world, the Earth, formed in just this way, gathered together an unimaginably long time ago, out of a cloud of gas and dust that had already been enriched by countless earlier stars that lived and died before the sun was ever born. The rock beneath your feet, the water in the oceans, the air that you are breathing slowly in and out as you rest, all of it was built from substances that were forged long ago in the hearts of ancient stars and scattered by their deaths and gathered up again to make our world. And this is the quiet, wonderful thread that connects you, lying here tonight, all the way back to the Big Bang itself. The simplest atoms in your body, the lightest ones, were made in those very first few minutes after the beginning of time. And the heavier ones, the carbon in every cell of you, the oxygen you breathe, the iron in your blood, the calcium in your bones, were forged later, inside stars, out of that early simple gas. Every single atom you are made of has a history that runs all the way back to the beginning of the universe. You are not separate from this great old story. You are the latest chapter of it. The Big Bang did not happen only far away and long ago. It happened here, to the very stuff that you are made of, and its story runs, unbroken, straight down to this quiet room and to you. Now, you may be wondering, through all of this, when? When did all of this happen? How long ago was the beginning? How old is the universe? And we can actually answer this with a fair degree of confidence, which is itself a rather astonishing thing, that we can put a number, and a real one, on the age of everything. The universe, as best we can tell, is about 13.8 billion years old. That is the span of time that has passed since the Big Bang, since the beginning of everything, down to this present moment, 13.8 billion years. It is, of course, an utterly unimaginable stretch of time. The number is so vast that saying it does very little. The mind simply cannot hold a billion years, let alone 13 and more of them. So let us not try to hold it directly. Let us instead find a gentler way to feel it. Here is a way that I find genuinely helps. Imagine that we took the entire history of the universe, all 13.8 billion years of it, from the Big Bang until now, and we squeezed it all down, in our imagination, into a single year. Just 1 year, running from the 1st of January to the 31st of December. On that scale, the Big Bang happens in the very first moment of the 1st of January, the very stroke of midnight as the year begins. And everything that has ever happened in all the history of the universe unfolds across the months of that single imaginary year. On that scale, our own galaxy, the Milky Way, forms quite early in the year. But our own Sun and our own Earth do not appear until very late, not until around the beginning of September, more than 2/3 of the way through the year. Life on Earth begins not long after that, as small and simple living things, but for month after month it stays small and simple. The great and familiar creatures come astonishingly late. The dinosaurs, for instance, do not appear until around the very end of December, and they are gone again just a couple of days later. And human beings, people like us. On this scale, where the whole history of the universe is a single year, our entire species, every person who has ever lived, all of human history, all of it, appears only in the last hour of the last day of the year. Everything you have ever read about, every civilization, every story, every life, has happened in the final few minutes before midnight on the 31st of December. And if the whole of human history fills only those final few minutes, then a single human life, your life or mine, is briefer still upon that scale. The merest flicker, a small fraction of the very last second before the great year turns. It sounds, when you first hear it, as though it ought to make a life feel small and fleeting, almost to the point of sadness. But I have always felt it quite the other way around. To be here at all, to be one of those brief, bright flickers of awareness in a universe 13.8 billion years in the making, is an extraordinary and improbable gift. Almost the entire vast history of the cosmos unfolded, with no one there to witness it. And here you are, in the last flicker of the great year, somehow able to look back across the whole of it, and to wonder, and to know even a little of the story of how it all came to be. That is not a small thing at all. That is very close to a miracle. I don't share this to make you feel small or fleeting or unimportant. Quite the opposite. There is something wonderfully calming in it, I think, when you let it settle. It means that you're a part of something almost unimaginably old and vast and grand. A story that has been unfolding patiently and beautifully for 13.8 billion years, and that has led through all those ages right here to this moment, to you, resting quietly in the dark. Your worries of the day, whatever they may be, are held gently within something so much larger and older and calmer than themselves. The universe is in no hurry. It has had all the time in the world, and more. And so, tonight, do you? Now, if you have been following along, or even if you have been happily drifting in and out, half towards sleep, there is a very good chance that a certain question has been quietly nagging at the back of your mind this whole time. It is the most natural question in the world, and nearly everyone asks it, and it would be wrong of me not to face it gently with you. The question is this: if the Big Bang was the beginning of everything, then what came before it? What happened before the Big Bang? It is such a natural question, and here is the honest and rather mind-bending answer. It may be that the question itself does not quite make sense, not because it is a silly question, but because of something very deep and very strange about what the Big Bang actually was. You see, when we say that the Big Bang was the beginning of everything, we may mean something even more complete than it first sounds. It may be that the Big Bang was not only the beginning of all the matter and all the space in the universe, but the beginning of time itself. And if time itself began at the Big Bang, then there simply was no before. The word before only has meaning if there is time for it to point back into. Asking what came before the beginning of time may be a little like standing at the very north pole of the earth and asking which way is further north. There is no further north. You are already at the top. In the same way, there may be no before the beginning. You are already at the very start of time. I'll be honest and gentle with you, though. We do not know this for certain. This is genuinely one of the deepest open questions in all of science, right at the edge of what anyone understands. There are thoughtful people who wonder whether there might, in some sense, have been something before, some earlier state, or some larger reality of which our universe is only a part. These are real ideas, explored seriously, but they are, for now, far beyond anything we can test or confirm. So the honest answer to what came before the Big Bang is a quiet and rather beautiful, we do not know, and we may never know, and it is possible that the question has no answer at all. And there is no shame in that. It is simply the edge of the map, the place where our knowledge runs out and the true mystery begins. There is a second question too, that often comes hand in hand with the first, and it is just as natural. If the universe is expanding, if space itself is growing larger and larger, then what is it expanding into? What lies outside it? What is on the far side of the edge? And here, again, the answer is gently surprising. As far as we can tell, the universe is not expanding into anything. There is no outside, no surrounding emptiness for it to grow into, no edge that it is pressing outward against. Remember the rising bread. But even that picture has its limits, because the bread expands into the oven around it, and the universe has no oven. Space is not swelling into some larger space beyond it. Space itself is simply becoming more of itself, stretching everywhere at once from within, with no edge and no outside and no center. There is no wall at the end of the universe, and no room beyond that wall. There is just space, growing gently larger, everywhere, all the time. Some people, reaching the edge of these questions, wonder whether our universe might be only one among many, whether there could be other universes beyond our own, each with its own beginning, perhaps countless of them, scattered through some far greater reality that we could never see or touch. It is a genuinely intriguing idea, and thoughtful people take it seriously. But I want to be honest with you. It is, for now, entirely beyond anything we can test or observe or confirm. It is a possibility, a wondering, not a known thing, and it may always remain so. And there is a kind of peace, I think, in simply admitting how much we do not know. We have worked out an astonishing amount about our universe, its age, its beginning, the making of its elements, the lighting of its stars. But right at the very edges, before the beginning, beyond the expanding, beneath the deepest nature of things, there is still profound and genuine mystery. And rather than being troubled by that, I find it quietly wonderful. It means the universe is still larger than our understanding of it. It means there is wonder left over, more than enough, surely, to last us all our lives. These are strange ideas, I know, and they can make the mind spin a little if you chase them too hard. So please don't chase them. Let them wash over you, gently, the way you might let a strange and lovely dream wash over you, without needing to make full sense of it. The honest truth is that the universe holds mysteries at its very heart that none of us fully understand. Mysteries about its beginning and its edges and its deepest nature. And there is something rather comforting in that, I think. It means the story is not finished. It means there is still wonder left, still questions worth asking, still mystery enough to last us all a very long time. And on that note of gentle mystery, let us turn to one more thing we have only recently begun to realize, that most of the universe is made of something we cannot even see. Here is a thought to rest with tonight, and it is one of the strangest and most humbling things we have learned about the universe in all our long looking. For all that we have come to understand, the expansion, the beginning, the first light, the forming of the stars and galaxies, it turns out that everything we can actually see, all the shining stars and glowing galaxies and drifting clouds of gas, all of it together, makes up only a small fraction of what the universe is truly made of. The great majority of the universe, most of everything there is, appears to be made of things we cannot see at all, and do not yet understand. We have given these unseen things names, but the names are really just labels for our own not knowing. The first of these unseen things we call dark matter. When astronomers carefully measured how the galaxies move, how fast they spin, how they hold themselves together, they found that there simply was not enough visible matter, not nearly enough stars and gas to account for it all. The galaxies behaved as though there were far more material in them, far more gravity holding them together than everything we could see could possibly explain. And so we came to believe that there must be a great deal of some other kind of matter out there, something that has gravity and pulls on things and holds the galaxies together, but that gives off no light at all, and that we cannot see with any telescope of any kind. We call it dark matter, simply because it is dark to us, invisible, unseen. And there seems to be far more of it in the universe than all the ordinary visible matter of the stars and worlds put together. What it actually is, though, what it is made of, remains, to this day, a genuine and unsolved mystery. And then there is something stranger still, which we call dark energy. For a long time, people naturally assumed that the expansion of the universe must be gradually slowing down, that the gravity of all the matter in the universe pulling inward would gently put the brakes on the expansion over time, the way a ball thrown upward is slowed by the Earth's pull. But when astronomers actually measured it carefully, they found the opposite. The expansion of the universe is not slowing down, it is speeding up. Over the vast ages, the growing of space has been getting faster, not slower, as though some mysterious force were pushing the universe apart, gently but relentlessly, overcoming the inward pull of all its gravity. We do not know what this force is. We call it dark energy, again just a name for a mystery, and it appears to make up the largest share of all of the universe, more than the dark matter, and far more than all the visible stars and galaxies. And yet we cannot see it, cannot touch it, and do not understand it. Let me put it together for you, gently, because the shape of it is quite something to hold. If you added up everything in the entire universe, then the ordinary matter, everything we can see, all the stars, all the galaxies, all the worlds, all the gas, everything that shines or could be touched, would make up only about 5 parts in every 100. Just 5. The dark matter, the unseen material holding the galaxies together, would make up something like 1/4 of the whole, and the rest, by far the largest share, something like 70 parts in every 100, would be that mysterious dark energy, gently pushing the whole universe apart, which means that everything we have ever seen, everything we have ever studied, all the shining wonder of the visible cosmos, is only a small sliver, a few parts in 100, of what the universe truly is. The overwhelming majority of it is dark and unknown and waiting, still, to be understood. People are working hard, even now, to solve these 2 great mysteries, all around the world, in quiet laboratories buried deep underground, shielded from every disturbance, and with great telescopes turned patiently toward the sky. Careful men and women are searching for any hint of what the dark matter might be made of, and any clue at all to what the dark energy might be. It is some of the most exciting work being done anywhere in science, precisely because the answers are still unknown, still waiting to be found. And there is a real chance that someone alive today, perhaps someone quite young right now, will one day help to solve it, and that the nature of the dark universe, which has kept its secret for so very long, may at last begin to give itself up. But that is a story for the years to come. For tonight, it is enough, and more than enough, simply to rest in the wonder of it, that the universe is so much larger and stranger and more full of hidden things than everything we can see. I find this not frightening at all, but rather wonderful. It means we are still, even now, near the very beginning of understanding. It means the universe is far vaster and stranger and richer with mystery than everything we can see. And it means that the great story of the Big Bang, for all we have learned of it, is still being written and still holds secrets we have not yet begun to unravel. There is so much left to wonder at, and wondering, after all, is a rather lovely thing to do as you drift off towards sleep. And so we come, gently, to the end of our long journey, the longest journey there is, really, all the way from the beginning of everything down to this quiet room, and to you. Let us gather up the whole of it now, softly, and hold it together for one last calm moment before we let it all drift away into sleep. We began with the oldest question there is: where did everything come from? And we followed the answer, step by gentle step. We saw that the universe is expanding, that the galaxies are all drifting apart, that space itself is slowly swelling larger everywhere at once. And we ran that expansion backwards in our minds, watching everything draw together, hotter and denser, until it pointed to a single beginning, the Big Bang, when all of space and time and matter began, together, from an unimaginably hot and dense start, and began to grow and cool. We watched the young universe cool and take shape, making the first simple gases in its opening minutes, then clearing at last from a glowing fog into transparent space, releasing that ancient light that still fills the sky today. We watched the long dark ages and the slow patient work of gravity gather the drifting gas until the first stars caught fire and the first galaxies turned and the darkness gave way to the light of the cosmic dawn. And we followed the stars themselves as they forged, across billions of years, all the richer substances of the world, the very substances that came together in time to make our sun and our earth and every living thing and you. And that is the thought I would most like to leave you with as you settle now toward sleep. You are not separate from this vast old story, watching it from the outside. You are part of it, the newest part, the latest chapter. The atoms that make up your body were born in the beginning of the universe and forged in the hearts of ancient stars. You are, quite literally, made of the Big Bang and of everything that has happened since. And in you, and in all of us, the universe has done something rather extraordinary. After 13.8 billion years, after all that expanding and cooling, all that gathering of gas and lighting of stars, all that patient building of worlds, the universe has at last produced something that can look back at it and wonder where it came from and tell its story softly in the dark. When you lie here and wonder about the beginning of everything, it is, in a very real sense, the universe wondering about itself. You are the cosmos, grown old enough and gentle enough to look back at its own beginning. I hope that thought brings you a little comfort, lying there in the quiet dark. It can seem sometimes, in the middle of an ordinary and tiring life, as though we are small and separate things, adrift in a universe that has nothing much to do with us. But it simply isn't so. You are woven into the oldest story there is, made of its very first light and its most ancient stars, as much a part of the universe as the farthest galaxy turning in the deep. The same beginning that lit the first stars and built the great wheel of our galaxy and forged the gold in the ground beneath you, also made the very atoms that are, at this moment, breathing slowly in and out as you rest. You belong here, in this universe, as deeply and as truly as anything possibly could. You are not a stranger passing through it. You are the cosmos itself, come quietly alive for a little while, and grown gentle enough to wonder and to rest. There is nothing you need to do with any of this. You do not need to remember it, or understand it, or hold on to a single word. The universe has been unfolding, patiently and beautifully, for 13.8 billion years, entirely without your help, and it will go on unfolding gently, long after tonight is forgotten. It asks nothing of you at all. It only carries you along, as it has carried everything along, from the very beginning, through all the ages, to this quiet and peaceful moment, here, now, in the warm dark, at the end of a long day. So let the whole vast story go now, and simply rest. Let your breathing slow. Let your body grow heavy and warm. Feel how gently you are held, one small and living part of a universe almost unimaginably old, resting quietly beneath the same ancient light that has been traveling toward you since the very beginning of time. There is nowhere you need to be, and nothing you need to do, and all the time in the world. Sleep now, gently, child of the Big Bang, and may your dreams be as soft, and as deep, and as full of quiet wonder as the great old universe turning slowly all around you. Good night.